Dear students, welcome to For This Academy. This is a e-platform for easy learning. Now, I am going to discuss the first chapter of physics for the class 10 of our SCERT textbook. You please have your textbook and a pencil while listening to the class so that all the worksheets and table could get filled. And you can note the points for future study also. Okay, we will be discussing all the text related problems in detail here. So, let's move on to the chapter. We have 4 chapters in our first part. Okay, the first chapter is Effects of Electric Current. In this chapter, the different effects of electric current and the related problems is discussed. Let's move on to the chapter, the effects of electric current. In the picture, so many electric devices. Okay, you have some blank points to be filled there. Okay, let's fill those points. The first is electric bulb, electric fan, then we have electric stove is there, induction cooker is there, mixer grinder or mixie is there, electric oven is there, and storage battery also. In all these devices, electrical energy is used and gives out some different forms of energy. Okay, let's fill the table and the next page. See which are the devices listed here. There is electric bulb, induction cooker, storage battery while charging, mixie. Then we can fill the blank spaces as electric stove and electric fan. Okay. In the case of electric bulb, what we use it for? We use it to get light. What energy change happens here? Electrical energy changes into light energy. For the case of induction cooker, we use it to get heat. What kind of energy change happens here? Electrical energy to heat energy. For the storage battery, while charging, we have to remember that while charging what kind of energy change happens, and while discharging what kind of energy changes happens in the case of storage battery. Okay, so let's see while charging. Storage battery, what we use to get electricity. Energy changes what? Electrical energy into chemical energy. But while discharging, what happens in storage battery? The chemical energy gets transformed into electrical energy. Then we have the point mixie. What we use mixie for? We use it to get mechanical energy. What kind of electrical change, energy change happens here? Electrical energy gets to mechanical energy. Next, electric stove. Let's fill the point as electric stove. What we use it for? We use it to get heat, and energy change, what is? Electrical energy to heat energy. For the case of electric fan, what is the use? To get mechanical energy. What energy change happens here? Electrical energy to mechanical energy. It is clear that electrical energy can be transferred into different forms of energy. For the case of bulb, the effect of current is light effect. For the fan, mixer, etc., it is mechanical effect. For the iron box, stove, etc., it is heat effect. So, the useful form of energy into which a device converts electrical energy is considered as the effect of electric current. You understand what is the effect of electric current? It is the useful form of energy into which a device converts electrical energy is considered as the effect of electric current. So, we noted so many effects of electric current, light effect, mechanical effect, heat effect, etc. Now we are what we have the next topic is heating effect of electric current. Okay, let's move on to the topic. We have so many devices which gives out heat energy while passing electricity, isn't it? Some of the devices are electric iron, electric heater, induction cooker, soldering iron, stove, etc. You know all those in all these electrical devices, electrical energy converts to heat energy. Okay, let's do an experiment using a nichrome wire, a 6-volt storage battery and some connection wires. Okay, see, the nichrome wire is represented by the letter R, is connected to a 6-volt battery. After passing electricity for some times, the nichrome wire becomes red hot. Okay, what kind of energy transfer happens here? This can be explained using our law of conservation of energy, which is stated as energy can neither be created nor be destroyed. It can only be converted from one form to another. Here what happens when we passes electrical energy for some time through that nichrome wire using a 6-volt battery, that electrical energy gets transformed into heat energy, which turns the nichrome wire into red hot. Okay, let's examine the circuit once more. Here R, which represents the nichrome wire with the resistance R. What is the unit of resistance? It is ohm. The nichrome wire, there is a voltmeter is connected in parallel to it. You have to remember the voltmeter is always connected in parallel to the device, and the ammeter which uses to measure current is connected in series. Okay, since what is the use of voltmeter? Voltmeter uses to measure the voltage V, and the ammeter uses to measure the current. Okay, so if the ammeter shows a current I ampere on applying a potential difference V across the resistor of resistance R ohm, we have the expression of current I as I is equal to Q by T. Then what is the expression for charge Q? Charge Q will be from the above equation. Charge Q is equal to I into T coulomb. You have to fill that. Q is equal to I into T coulomb. Now, we know that some work has to be done to move any object from one point to another. Okay, similarly, in this circuit, some work must be done to move the charge Q from one point to another to constitute the current. Here, that work done is our potential difference V. You understand that? We know that to move any object from one point to another, we have to apply some work. Okay. Similarly, to constitute the current, the charges has to be moved from one point to another. Here, that work is done by the potential difference V. That is what I told first. Some work must be done to move the charge Q from one point to another to constitute the current. Here that work done is our potential V. Okay, let's have the standard definition for our potential difference as the potential difference between 2 points will be 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to the another. Okay, what is potential difference? Potential difference which is used to move 1 coulomb of charge from one point to another will be 1 volt if 1 joule of work is done. Okay, that is the potential difference between 2 points will be 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to another. That is explained here correctly. That is explained here in detail. 1 joule of work is required to move 1 coulomb of charge under 1 volt potential difference. Hence the work W to be done to move 1 coulomb of charge under a potential difference V will be W is equal to V joule. Okay, hence so the work to be done to move a charge Q under a potential difference V is W is equal to Q into V. Okay, W is equal to V joule here. See, W is equal to V joule when 1 coulomb of charge to be moved from one point to another. Then the work done W is equal to Q into V to move Q amount of charge from one point to another. Okay. Now we have to find an expression for the electrical energy. Let's see it in our let's see what happens. Okay, which connect voltage V, current I, resistance R. The expression for Ohm's law, as you all know, is V is equal to IR and I is equal to V by R and R is equal to V by I. Okay, always remember this triangle which connects the voltage I and resistance. Now let's find an expression for heat energy. We are avoiding the power here. We directly find the heat energy from work. Okay, it will be easy for you. We know that energy is equal to work done. So first we should find the expression for work. Since we studied the explanation for potential, from that we have the work needed for 1 coulomb of charge to move from one point to another is W is equal to V. Hence the work needed to move Q amount of charge is W is equal to QV. Since we know that Q is equal to IT, therefore work done W is equal to V into I into T. Weight. Okay, W is equal to weight, just to recall. Okay, this is the heat energy produced when I amount of current flows through a conductor for a time T when a potential V is applied. Okay, so we derive the expression for work. We know that the work is equal to energy. Here the energy is in the form of heat. So we got the expression for heat energy as H is equal to V into I into T. Okay, when we are substituting for V is equal to IR and I is equal to V by R in equation 1, we will get the other two expression for heat energies also. So this is the 3 equation for heat energy, that is H is equal to VIT, H is equal to I square RT, H is equal to V square T by R. Okay. Joule's heating or ohmic heating. We know that the process of producing heat in a conductor when a current passes through it is called Joule's heating or ohmic heating. It is nothing but in any conductor, if the current passes through it, an amount of heat is produced. This production of heat is called Joule's heating or ohmic heating. Now another important law we have to study in this chapter is Joule's law, which is we already derived that expression here, but we have that in a law form as. Now dears, what we have to study is Joule's law, an important law in this chapter. This law states that the heat generated H in a current carrying conductor is directly proportional to the product of the square of current I in the conductor, the resistance of the conductor R, and the time t of flow of current. That is, the heat energy produced is directly proportional to the product of I square R and T, which is given by H is proportional to I square RT. Therefore, H is equal to I square RT Joule. Here, Joule is the unit of heat energy which is represented by capital letter J. Here, I is the current, the unit is ampere, R is the resistance, unit is ohm, and time T is the T is the time which is in second. Okay. Next, we know according to the Joule's law, the heat produced H is equal to I square RT. We are checking which are the factors that affects the heat energy more. For that, let's fill this table below and find out which factors factor mostly affect the production of heat energy. Okay, for that we have different values of R, different values of I, different values of T, and let's calculate how much is the heat energy. We can have the table as follows, like this. From this it is seen that the three main factors which affects the heat energy produced is no doubt it is I, R and T. It is seen from the table that when the value of current is 2I, that is twice than I, then the heat energy produced is 4 times the original. Okay, that is 4H. And similarly, when the value of current is became halved, then the value of heat energy will get decreased to 1 by 4. Okay, the main factor which affects the value of heat energy is then current, and then resistance and time have same effect on heat energy. Okay. Then now let's see. Okay, so what next? Analyze the table and find out the factor that influence heat the most. It is current. When the current becomes twice, the value of heat energy becomes 4 times the actual one, and when the current becomes current is decreased to half, then the heat energy is decreased to quarter. Okay. We have one more experiment here. We will discuss it later in this chapter. Okay, let's move to the next page. Here, what we can see, Joule's law is useful in devices that make use of heating effect of electricity. And we have 2-3 problems are solved here. Let's see. Let's read the question first. Whenever you get a problem, first you have to read the question. Okay, here, how much will be the heat developed if 0.2 ampere current flows through a conductor of resistance 200 ohm for 5 minutes? What are the quantities are given in the problem? Should write one by one in the right part of your notebook. Okay, then here we have R is equal to 200 ohm, I is equal to 0.2 ampere. R is the resistance in ohm, I is the current, the unit is ampere, 0.2 ampere. But time should be, the SI unit of time is second, so minute should be converted into second. For that 5 minutes is 5 into 60 seconds, so 300 seconds. So we have, actually we have 3 expression for heat energy, that H is equal to V into I into T, H is equal to I square RT, H is equal to V square by R into T. But we have the quantities here is R, I and T, so we have to use the expression H is equal to I square R into T. Okay, so putting all the values, we will get H is equal to 2400 joule. Therefore, heat generated is 2400 joule. We have to make this joule into calories. For that, we know that 4.2 joule is 1 calorie. Therefore, 2400 joule is how much calorie? 2400 by 4.2, which is 571.43 calorie. How much? 571.43 calorie. Okay. This is the we already discussed about the 3 different expression for the heat energy. H is equal to I square RT, H is equal to VAT, H is equal to V square by R into T. So no need of explanation here. So next is what? Let's find out the heat developed in 3 minutes by a device of resistance 920 ohm working under 230 volt. Okay, what are given here in this question? 3 minutes, so means T is equal to 3 minutes, that is minute should be converted into second, that is 3 into 60 second. Then what is given? Resistance R equal to 920 ohm, voltage V is equal to 230 volt. Okay, so we have using the equation H is equal to what are the 3 quantities? V, R and T. So which equation could be used here? V square by R into T. So we will get 10,350 joule. Next we can solve this problem using equation H is equal to I square RT or H is equal to VAT. In all these cases, the heat energy will be the same, 10,350 J. Here I is equal to V by R. What is V? 230 by 920 will be how much? 0.25 ampere. So H will be equal to, I is what? 0.25. So H is equal to 0.25 the whole square into 920 into 180. That will be also 10,350. Okay. Now we have one more question here, which is we have the details of 2 heaters. Okay, heater A and heater B. There is one more problem that you people check, that you people have to do yourself in your book. Okay, everything is given. The time here is 5 minutes. So 5 to be converted into 5 to be converted into second, and do this. Okay, here is one heater 1 230 volt working under voltage 230 volt, resistance 1150 ohm, working time 5 minutes. Same is the voltage. Resistance is for heater B, it is a low resistance, working time same time. Two heaters work for the same time under same potential, only the resistance is different. In one case in which resistance is higher, the heat energy produced is what? Lesser, that is 13,800 joule. In case of heater with low resistance, the heat energy produced is 34,500 joule. Why does the heater having low resistance get heated more? What is the reason? V square. Why does the heater having low resistance get heated more? We know that the factor which affects the heat energy more is the current, the amount of current. If the resistance is low, then the current is high. So low resistance means high current, so he get heated more. Okay, next, in which way does the change in resistance influence the heat developed? I already discussed it. That is, when the resistance is low, then the current is high. If the current is high, the heat produced is high, and vice versa. Find the current in the heaters A and B and compare the heat developed. Current is how much? For the first heater, I is equal to V by R, that is 230 by 1150 ohm, which is 0.2 ampere. For the case of heater B, it is 230 by 460 ohm. 230 by 460, it is 0.5 ampere. Okay, in which means the heater with low current is which one? Heater A, in which heat energy produced also less. The heater with high current, that is heater B, in which the heat energy produced is high. Okay, so we have discussed about the effect of resistance on change in the current and the production of heat. Okay, let's have the next section in our next class. Hope you all like my classes. Hope you can follow my classes well, and you have to watch and share my classes. If you have any doubt, you can leave a comment in the comment box, so that I could improve my classes more better. Okay. Okay guys, I will come with the next class soon. So take care and study well. Okay, thank you.